How did birds first take off? It took 150 million years for feathered dinosaurs to master flight and become the birds we see overhead today. In 1993, Jurassic Park helped inspire 9-year-old Stephen Bressat to become a paleontologist, so Dr. Bressat was thrilled to advise the producers of last year's Jurassic World Dominion on what scientists had learned about dinosaurs since he was a child. He was especially happy to see one of the most important discoveries make it to the screen. Dinosaurs that sported feathers. But judging from the emails he has been receiving, some moviegoers did not share his excitement. A lot of people thought it was made up, said Dr. Bressat, a professor at the University of Edinburgh. They thought it was filmmakers trying to do something crazy. Far from crazy, feathered dinosaurs have become a well-established fact, thanks largely to a trove of remarkable fossils that have been unearthed in northeast China since the mid-1990s. Now Dr. Bressat and other paleontologists are trying to determine exactly how feathered dinosaurs achieved powered flight and became the birds that fly overhead today, an evolutionary mystery that stretches more than 150 million years. The first big clue to the origin of birds came in 1861, when quarry workers in Solnhofen, Germany, found a spectacular fossil of a 145 million year old bird that came to be called Archaeopteryx. It had feathered wings like living birds, but also had traits found in reptiles, such as teeth, claws, and a long bony tail. Charles Darwin, who had published on the origin of species 2 years earlier, was delighted. Archaeopteryx looked like what Darwin would have predicted if birds had evolved from reptilian ancestors. It is a grand case for me, he told a friend. Grand as it might have been, Archaeopteryx did not close the case. It did not, for example, reveal which group of reptiles gave rise to birds, nor did it track how those ancestors evolved wings from nothing. In the 1970s, John Ostrom, a paleontologist at Yale University, identified similarities in the skeletons of birds and ground-running dinosaurs called theropods, a group that includes the Velociraptor and the Tyrannosaurus rex. But no theropod fossils preserved wings, let alone feathers. Without more evidence, Dr. Ostrom and other paleontologists argued fiercely about the origin of birds for decades. In 1996, Pei Ji-chen, a paleontologist from the Nanjing Institute of Geology and Paleontology in China, came to a paleontology meeting at the American Museum of Natural History in New York, where he handed a packet of photographs to Dr. Ostrom. The pictures showed a fossil of a dinosaur with a fringe of what looked like rudimentary feathers. Dr. Ostrom was so astonished he had to sit down. The 125 million year old fossil, now known as Sinosauropteryx prima, came from the Liaoning province of northeastern China. It was exquisitely preserved in a Pompeii-like blanket of ash. Since then, a steady stream of feathered dinosaur fossils has emerged from the region. There are many thousands of feathered dinosaurs now, Dr. Bressat said. As more fossils emerged, paleontologists realized that theropods were not the only dinosaurs with feathers. Other species had simple versions, which looked more like wires than the complex network of interlocking filaments found in bird feathers today. Paleontologists now suspect that the ancestor of all dinosaurs had feathers, and recent discoveries hint that feathers preceded dinosaurs. The closest relatives of dinosaurs were pterosaurs, which flew like bats with membranes stretching from their hands to their sides. It turned out they had simple feathers, too. The first simple feathers may have originally served as insulation. The largest dinosaurs may have been able to use the large volume of their bodies to retain heat, which is why they appear to have lost feathers, just as elephants have lost most of their hair. In theropods, on the other hand, more elaborate feathers evolved. Some resembled fuzzy down. Others evolved complex feathers that could form sheets, the first wings. Theropods could not use their early wings to fly. Some horse-sized species sported wings the size of laptop screens. Dr. Bressat speculated that dinosaurs used these more elaborate feathers as displays during courtship. By 160 million years ago, theropods had exploded into a bizarre menagerie of feathered forms. Julia Clark, a paleontologist at the University of Texas, and her colleagues have studied fossils discovered in Hebei province in China of a stunning and bizarre species called Kaihongjuji. Fossilized pigments in the feathers suggest that its body was black, while its head and shoulders were an iridescent rainbow. It's hard to figure out how Kaihongjuji used its feathers. Modern birds have asymmetrical feathers on their wings, which help steer the flow of air to generate lift, but Kaihongjuji had asymmetrical feathers only on its tail. Theropods may have initially used their feathers to generate lift as they ran. That ability might have allowed them to climb slopes faster, or even scale the sides of trees. Feathered dinosaurs like Kaihongjuji lacked the muscles for powered flight like birds, but they might have jumped and glided in ways scientists have yet to figure out. These organisms are just weird, and I think they defy our logic, said Jamie O'Connor, a paleontologist at the Field Museum in Chicago. Feathered dinosaurs were more than just intermediates on the path to birds as we know them. They survived for tens of millions of years. They were clearly good at whatever they were doing, Dr. Clark said. Archaeopteryx belonged to one branch of the dinosaur tree that later adapted to fly longer distances, but paleontologists are still split over just how well it could fly. While Archaeopteryx had asymmetrical feathers on its wings, it did not have a sternum that could anchor powerful flight muscles. Later, roughly 130 million years ago, early birds split into two major branches, both of which evolved independently into powered flyers. The lineage that led to all living birds is known as the ornithuromorphs, but it was the other branch, called the enantornithines, that dominated the skies for tens of millions of years. On a superficial level, enantornithines look a lot like birds today, but Dr. O'Connor and her colleagues are uncovering a lot of strange biology within them. Living birds, for example, are typically born without feathers or just a downy fuzz, and then grow their feathers across their whole body. They gradually molt feathers as adults so that they never lose the coat that keeps their bodies warm. But enantornithine birds seem to have developed feathers in a radically different way, as Dr. O'Connor and her colleagues argued in a recent study. They hatched with bare bodies but with fully feathered wings. As they matured, they grew plumage on their bodies, but as adults, they molted their body feathers all at once. Until their new feathers grew in, they had to survive without their insulating plumage. This lineage of birds survived until 66 million years ago, when an asteroid struck the Earth. Roughly 3/4 of all species on the planet were wiped out, including all feathered dinosaurs except the ornithuromorphs. Dr. O'Connor and other paleontologists are investigating why those birds survived when all other feathered reptiles vanished. The debris from the impact caused widespread wildfires, followed by darkness and a plunge in temperatures. Terrestrial ecosystems collapsed. Feathered dinosaurs that ate leaves or small animals might have starved, but birds had evolved beaks that allowed them to eat the vast quantities of seeds buried in the ground. Dr. O'Connor thinks other factors may have also been at play. After thriving for 70 million years or more, enantornithines may have suddenly become vulnerable in the cold weather after the asteroid when they molted all their feathers at once. You throw them in an impact winter, where now global temperatures have decreased and there's resource scarcity, it's just going to push them over the edge, Dr. O'Connor said. If you believe what you read in the papers, Sankar Chatterjee ought to be the crown prince of paleontology. 6 years ago he announced that he had found the world's oldest bird fossil. It beat the previous record not by a mere 1 or 2 million years but by 75 million. With one quick kick, it seemed, Chatterjee sent paleontologists who thought they knew something about how birds had evolved tumbling in the dust. Discovering the oldest fossil of anything is obviously wonderful for a paleontologist's career. The fossil instantly becomes the centerpiece of any future theory about how an animal evolved and what it evolved from. And not incidentally, the fossil finder becomes just as important. In 1974, for example, paleoanthropologist Donald Johanson found Lucy, the oldest, most complete fossil of an upright human ancestor. The The discovery gave him so much clout that he could later found and head his own research organization, the Institute of Human Origins in Berkeley. Chatterjee, however, is not the head of any Institute of Avian Origins. He still lives in Lubbock, and he still teaches at Texas Tech University, where he's been for 12 years. Instead of reaping the benefits of a major discovery, he's at the center of a storm of controversy. A number of critics consider his bones to be a hopeless mess of fragments that doesn't even come close to supporting his claim to the oldest bird. These critics also attack Chatterjee's professional conduct. Only in the past year has he begun to publish his results, and only in piecemeal form at that. Considering all the attention he garnered in 1986, it perplexes people that Chatterjee took so long. His more vocal critics say his work is misleading and incapable of supporting his